Hello physics students. Today we're going to learn about conservation of momentum as it relates to collisions. You all did a collisions simulation yesterday, and we're going to kind of go through some of the ins and outs of the math, do a couple of examples, and get you on your way to working through the homework problems. We're going to look at two different kinds of collisions. First is called inelastic, second is called elastic. So we're going to start here with inelastic collisions. Inelastic collisions are when things collide and stick together. So you can imagine two cars get in a T-bone accident and they stick together and slide after they hit. Could be a football player tackles another football player. That's an inelastic collision. They stick together. Could be someone target shooting and shoots a bullet into a target, or someone throws you something, you catch it. When you catch that object, it's an inelastic collision between you and that object. You stick together. So let's do a couple of examples with inelastic collisions. I'm going to just draw some carts similar to what you were working with yesterday. We'll say this is our red cart, and it's 2 kilograms, and it's going initially to the right at 5 meters per second. And it's going to collide elastically with a blue cart with a mass of 1 kilogram. That's going to the left at 4 meters per second. What we need to remember is that with these conservation of momentum problems, it's called conservation for a reason. It means that the momentum initially, before they collide, has to equal the total momentum after they have collided. So before they collide, we've got momentum of the red cart, momentum of the blue cart, that we're going to add together. Momentum is a vector, you can add these two values together. After they collide, you've got just one momentum because they're going to stick together. This is an inelastic collision, they have to stick together. So we've got our P, we can just call it together, because they're going to stick together as one. So before they collide, our momentum is mass times velocity. So 2 kilograms times 5 meters per second. For blue, 1 kilogram times 4 meters per second in the opposite direction. So direction is very important. And together they have a mass, once they couple together, of 3, or 2 plus 1, times some final velocity. So simplifying, you got 10 minus 4 equals 3v. So this is 6 equals 3v, and v equals 2 meters per second. The fact that it came out positive implies that it's to the right. So let's just double check. I've got this set up with red and blue. Red's twice the mass of blue. Red's going to the right at 5. Blue's going to the left at 4, and I've selected an elastic collision. Double check. Boom, they stick together and they move at 2 meters per second. Next example. This time, our first cart is going to have a mass of 3 kilograms. And it's initially going to be moving to the right at 6 meters per second. And our other cart is going to have a mass of 2 kilograms, and it's going to be moving to the left at 9 meters per second. What's going to happen after they collide? Well, we know the initial momentum has to equal the final momentum. So 3 times positive 6 plus 2 times negative 9, because it's going the opposite direction, equals their masses together times some new velocity. 18 minus 18 equals 5v. So we've got 0 as a total momentum on the left, which means we have to have 0 as a total momentum on the left because v is 0 meters per second. So, in other words, they should hit and stop. They both have 18 units of momentum, one's forward, one's backwards. So they have to cancel out and they have to stick together. So if they're not going to have any momentum and they're stuck together, they have to have 0 velocity. So let's check this out. We've got 3 kilograms moving at 6 meters per second, and we've got 2 kilograms moving at -9 inelastically. have them go, boom, they stop. Let's move on to elastic collisions. Elastic, just like elastic of a rubber band or elastic waistbands, they do something and then they bounce back, right? You stretch out a rubber band and then it bounces right back. You stretch out a bungee cord, it bounces right back. Elastic means things go back. So an elastic collision is where the objects hit and bounce off each other. They do not stick. Let's do an example. Got a 1 kilogram cart. It's got a little spring on the front of it. This is going to be our red cart. It's going to be initially moving to the right at 5 meters per second. It's going to collide elastically with a blue cart that has a mass of 3 kilograms and was initially moving to the left at 1 meter per second. So this is our initial setup. Afterwards, I'm going to give you a piece of information. I'm going to tell you that the red cart has a final velocity of 4 meters per second to the left. We want to know what the heck happens to the red cart. Sorry, the blue cart. So, initial momentum has to equal our final momentum. Initially, we've got 1 kilogram multiplied by 5 meters per second for the red cart, plus 3 kilograms multiplied by negative 1 meter per second for the blue cart, equals, finally, we know the red cart, which is 1 kilogram, is moving to the left at 4, so it'll be negative 4. And the blue cart is 3 kilograms, moving with some velocity we don't know. Simplify, you've got 5 minus 3 equals negative 4 plus 3v. So this would be 2 equals negative 4 plus 3v. Add 4, you get 6. It gives us a velocity of 2 meters per second for the blue cart, which implies, since it's positive, that it's to the right. So let's check. Here's our collision carts. You got the little springs on them. Velocities and masses match our problem. Start the simulation. And our blue cart moves to the right at 2 meters per second. Let's do one more elastic example. Let's have a 1 kilogram cart going to the right at 3 meters per second, and it's going to collide elastically with a 3 kilogram cart. So put a little spring that was initially going at 1 meter per second to the left. So for our initial momentum, initially we've got a mass of 1 with a velocity of 3. For the left cart, for the right cart, we've got a mass of 3 with a velocity of negative 1. And if you notice, that's going to give us 3 minus 3, or 0 units of momentum total before they collide. Right, the momentum before they collide, the total is 0. 3 units and negative 3 units cancels out. Which means we have to have 0 total units of momentum after they collide. And so we have an interesting situation. This is kind of like the second example we did with inelastic, where they both objects had the same momentums but opposite in that case. With the inelastic problem, they can have 0 momentum afterwards by just hitting and sticking together, hence the term inelastic. Here we have an elastic collision where they're going to hit, but they have to bounce off of each other in such a way that they have 0 total momentum, which just means, as you'll see in the simulation in a second, they're going to maintain the velocities they initially had, just in opposite directions. They're essentially going to hit and bounce off of each other and maintain their speeds. So let's take a look. Oops, got to reset it. Start. 3 to the right, negative 1 left. Now it's just 3 to the left and 1 to the right. So just finishing up our calculation here. In most problems, we'll give you one of their final velocities, but in this case, where their momentums are exactly the same, they just hit and bounce off of each other with identical momentums. So the 1 kilogram is just going to spin around and go the opposite direction, and the 3 kilogram is also going to do the same. Let's actually do one more elastic example. 1 kilogram cart moving to the right at, let's say, 2 meters per second, and it's going to collide elastically with a 1 kilogram cart that was at rest. What might happen in this case? Well, again, our initial momentum would be 1 kilogram times 2 plus 1 kilogram times 0. And that's going to be our initial momentum, and that's just going to be 2 units of momentum, 2 plus 0. So we have to, again, have 2 units of momentum afterwards, and they have to bounce off of each other. They can't stick together. And so let's take a look just at the simulation, but before we even do that, kind of visualize in your head. You've got exactly the same masses, one's not moving, they're going to collide, and afterwards we have to maintain the momentum we had before. So, what might happen? Think when you've played billiards and you've hit one billiards ball with another, one was moving, one was not. Sometimes, if you hit them just right, you can get what you're about to see happen. 2 meters per second, they're equal mass, going to be elastic. They hit, the first one stopped, and the second one takes off going the exact same speed. So what we ended up seeing in this special case is that the first object, whose mass is 1, stops, transfers all the momentum to the second car that is now moving with the same momentum.